test. Hello everyone, mic test. Hello Chris, or rather Dallas, Keaton, Hattie, RNH, CY, Jamie, Li Ling, Lina. Can you all hear me? Hello, hello, mic test. Mic test, mic test. You all can hear me. How come I cannot hear from my phone? Okay, what matters is that you can hear me. That's good enough. I'll investigate my phone issue later. Okay, so thank you all for being here. Okay, welcome to tonight's Facebook Live, brought to you by Mastering Heuristics. So if you haven't already, if you haven't downloaded the notes are available at mathsheuristics.com/blog. Okay. So today we'll be continuing lesson 4 out of 10 of the SA2 Heuristics Revision Series. And also the replays are available at mathsheuristics.com/blog. Okay, if you haven't downloaded them, they'll be available. If you haven't watched them, they'll be available there, at least until the end of this year. Okay, and today we'll be covering on unit transfer method part 2. No, my phone is not muted. There's volume to it. Okay, so a bit about myself, but I think you already know this. We've all began doing Facebook Live coaching since August 2017. So the relevant milestones here is that we have also started teaching with Zoom in 2018 to full-time online classes for P3 to P6 math. Okay, then this is my boss, Mr. Sunny Tan. He established Maths Heuristics back in 2008, but I only joined the company around 2011. Actually, it's 2011 January, when I was still studying in NTU. At that time, in 2011, he said that his 5-year aim is to see every student in Singapore use the heuristics method, and it doesn't matter where they learn it from. And true enough, everyone these days are teaching heuristics. So for the notes themselves, right? Okay, for the notes themselves, let me just leave this over here. You can try to download it first. Look for the first post. Okay, look for the first post. So this is the set of books that my boss and my mentor has written. And today I'll be talking about a few chapters, a few skill sets from the unit transfer method at P5 and P6 book. Okay? Jai Prakash, you're using your father's account. Please don't do anything to disgrace him. Okay? So let me just pin this up in the link below first. Yeah, those are the notes. So if you found this useful, please like and share so that more people can benefit from this. Alright? Now, once you're ready, let's get this show on the road. Okay, there's always something wrong with this. This is supposed to be half 1/3. Hello, Ian. Hello, Dexter. Hello, Wykit. Okay, let's get this show on the road. There's like 5 questions today if you've already downloaded it. Okay, so I need to cover this real quick. So don't worry, I'll make quick work out of this. So in guided example 1, you see that Vera, Leroy and Tarita each donated some money to charity. The total amount of money donated by Vera was half the total amount of money donated by Leroy and Tarita. So allocate your units first. Okay, 1 will go to Vera, 2 will go to the total amount donated by Leroy and Vera. Then next up, the total amount of money donated by Leroy was 1/3 of the total amount donated by Vera and Tarita. Allocate your units first, and Vera donated $168. How much did Leroy donate? So to deal with this over here, what you want to do is to list them out first. Between Vera, okay, define out the problem first. Between Vera, Leroy and Tarita. Okay, we know that Vera donated 1 block, Leroy and Tarita donated 2 blocks. And between Leroy and Vera and Tarita, Leroy donated 1 red block, while Vera and Tarita donated 3 red blocks here. Okay, so once you have all these defined out already, my next question is there anything that we can do to make all the units the same first? Okay, anyone? Okay, I'll answer you all in a while. But for now, what do you have? Okay, what can we do from here after we've listed out everything? In fact, this kind of problem is pretty common in several forums these days. You all are so fast. Is it okay if you use ratio? Yeah, you can also do that. Can make total the same. Okay, thank you, Lina. That is correct. Okay, Lina is saying you want to make the total the same. That is correct. And why do we make the total the same? Because over here, what they are saying is, here's another way you can see this. between the blue representation and the red, okay, we can think of this as Vera donated 1 block, L and T donated 2 blue blocks worth. And for the red ones, because they donated a certain amount of money to charity, you can think of one of these red blocks as being donated from Leroy. Vera and Tarita donated the other 3. But you can also see that 3 blue blocks will represent the same amount as 4 red blocks here. So that's why we want to make the total the same. And in this particular problem, we are making use of the repeated identity, which is one of the chapters in the unit transfer method at P5 and P6 book. So when we got this ready, once you have identified that the total amount is the repeated identity, we can make them the same. We can multiply them to their lowest common multiple, and in doing so, we will cut all of them to the same unit length first. So, okay, never mind. So when we do this, we end up with 12, we end up with 9, we end up with 3, we end up with 12, end up with 8, end up with 4. Okay, I'll answer you all in a while. You all try to go to the block site itself, then you refresh the block and see whether you can find it. Yeah, so once we have made them all the same, we can see that Vera donated 4 units and Leroy donated 3 units worth. So to find out how much did Leroy donate, this would just be, okay, find out the value of 1 unit first. And then you, divide by 4, will give you 42. And 3 units will be 3 times 42, will give you 126. So the answer here is $126. Alright. Okay, is everyone okay? So for the notes themselves, okay, let me try to put the comment over here. If you haven't downloaded it already, please come here and download it first. mathsheuristics.com/blog first post. If you don't see it, try to refresh your phone or clear its cache first. Okay? Yeah. So congratulations to Ian, Kiliang, Victor, Melvin, Agnes, Jennifer, Jen, and who else? Okay, so this idea is on the repeated identity. So next one, number 2, a stationery shop owner had 352 red files and blue files. After he sold 2/5 of the red files and 75% of the blue files, 75%, change this to a fraction first, so that it becomes easier for you to deal with the units allocation. He had 50% as many blue files as red files. So 50%, change this to a fraction, 1 out of 2. Okay? Then it becomes easier for you to deal with it. Okay, Ian, later I show you towards the end. Alright? Yeah, Jamie, you're correct. Okay, so now how do we go about to deal with this problem? So let's understand what the whole situation is about. First, the stationery shop owner had 352 red and blue files. This was your before. Now within these two little fractions over here, they contain information about your before, your change, and your after. Eh? What happened to the chat? Okay, wondering why I didn't respond. Yeah, you have to chat inside here only. Sorry about that. Hang on. That's a bit. Okay. What's wrong with my phone? Oh. Okay. Alright. Sorry about that. Little delay. Okay. So the last part here is that he had half as many blue files as red files. So 2 goes to red, 1 goes to blue. Okay, how many blue files had he left? Now to deal with this, we will be using equal concept. And this is also from one of the chapters from the unit transfer method P5 and P6 book. Now what is equal concept? We use equal concept when the fraction of a set is being compared with the fraction or a proportion of another set. Okay, like you all seen questions like half of what A has is the same as 2/3 of B, that kind of thing. This is one of those examples, but in this case we can apply it here. Red, blue, total, sold, remain. Okay, let's draw this out first. How many marks would this be? Probably about 3 to 4. Some people there were wondering too. Yeah, I think it's when they cross-post this, then this issue would arise. Go buy iPhone 11. You buy for me, okay? You buy for me, I don't mind, because iPhone 12 is coming out. But anyway, so okay, so let's see what we have. For the red files, right? You had 5 blocks of red files and you sold 2 of them. The remainder here will be 3. Then the next part over here for the blue files. Okay, maybe I use red, the color red for the red files. And for the blue files, I will use blue. Yeah, I had a total of 4 blocks at first. I sold 3 blocks and now I have 1 block remaining. Okay, so now the last part is how do we deal with this after result, which is what is left. He had half as many blue files as red files. How or what are we going to do? Okay, so what they are saying over here is that this ratio must be in the form of, okay, for blue to red remaining, they have to be in the ratio of 1:2, but we have a ratio of 1:3 over here. In fact, the number is 1, this number here is 3, but can we say that the ratio is 1:3? No, not every question can use the table. Not everyone. But for those that can use table, you use it to organize your info. So now what can we do next? We can say that this will be, we want to have it in the form of 1:2, but we can't do it directly here. So what we can do from here is we list out certain equivalent fractions first. Okay, and you will see that when this is 3:6, you can have 3 blocks for the blue and 6 blocks for the red. Correct? Because over here 3 is not divisible by 2, and over here 2 is not divisible by 3, and 4 is not divisible by 3. So we cancel out these two possibilities. For this to be in the form of 1:2, we use 3:6, and we see that we can multiply this by 3 and we can multiply this by 2. So when we do this, right, we will obtain 4, 10, 12, and 9. Okay? So the idea here is if you can make something the same, try to do it first. Try to equalize the units first, and that will simplify the problem by a lot. By doing this, you don't have to resort to using units and parts. But for certain problems, you will need to use units and parts. So when you say you don't understand, please specify which part you don't understand. Then I can zoom in on that. So far, everyone else following? Okay, Lina, yeah, that's exactly correct. That's exactly what I'm doing. So now that we've obtained this ratio of 1:2, we want to see that, we want to look back at the question for further information, and we see that the stationery shop owner had 352 red and blue files. So we will make use of the total number of units here. A total of 22 units will represent 352. So 1 unit will be 352 divided by 22 to give you 16. And how many blue files had he left? He will be left with 3 units over here. So that will just be 48. Okay? So this would be your answer. I don't understand the part where you make both the ratio the same. Okay, so over here the idea is, you see he had half as many blue files as red files remaining. Correct? But you see that over here, you end up with blue units and you end up with red parts over here. So you want to find some way for this ratio to become 1:2. For the blue to the red to become 1:2. And to do this, we will list out the equivalent fractions, or rather, equivalent ratios, and see what works. Alright? I can't explain the whole thing again. I can only zoom into specific parts because I have like 5 questions today and I'm only at the second one. Okay, Wayne, Melvin, Jamie, y'all got it? Okay, so is that clearer? Maybe I try to draw out a model for you. Okay. Okay, let's say this is your red files remaining. You got 3 blocks of them. And for your blue files, you got 1 block remaining. And this is half, the blue block is half that of the 3 red blocks length. So in order for you to compare them uniformly, what you want to do is you want to cut it in such a way that they end up with the same length, representing the same amount. So the multiplier here is times 2, this one is times 3. Okay, so that's the main idea. If you got it, please spam the like button. Alright. Yeah, Ian, you're correct. Okay, so there's a lot of ways to do this. Model is also one of them. But I think for this problem, it may be a bit harder. Alright, okay, see all the likes flooding throughout. Okay, please stop using the GIFs over here. Okay, it will take up a lot of space. Excuse me. Just had my dinner, that's why I'm like kind of... Yeah, Janelle, you're correct already. Okay, good. But if you have something to clarify, please zoom in to where you want to clarify. If not, it's very difficult. Yeah, so next one, number 3. In the figure below not drawn to scale, the ratio of the biggest square A to the medium square C of the area of the biggest square A to the area of the medium square B to the area of the smallest square C is 8:5:3. So if 25% of the biggest square is shaded and 3/5 of the medium square is shaded, what percentage of the whole figure is not shaded? So first things first, change your 25% to a fraction first. This will be 25 out of 100, and it simplifies down to 1 out of 4. Okay, there seems to be like a lot of info, so let's try to distill this first. I'm trying to eat now. I eat first. Hey, welcome, Janelle. Okay, so here, there's a lot of ways you can represent this problem, but this is what I would recommend because you would be able to see everything at one glance. You'll be able to retrieve all the information that you need at one glance. You want to organize them like this: total, shaded, and unshaded. Okay, so you all draw this out first. Okay, I'll give you all the answer in a while. When will you post the replay? For Facebook itself, I think it's like you give it about 5 minutes after the lesson, it should be able to process it really. Okay, so once you got this ready, the next thing you want to do here is to list out what you have. Biggest square A is 8, square B is 5, square C is 3. So the total here is 8:5:3. Now, we see that 1/4 of the biggest square is shaded. So my next question is, how many units of A is shaded? Okay, Victor, I can tell you your answer is definitely wrong because they're asking you for a percentage. Okay, for A, how many units is shaded? You all know? Why is my thing like not working like that? Okay, hang on, let me see my phone. It is frustrating. Okay, 25% of the whole. Yeah, okay, 20, no. Yeah, how many units would that be then? 25%, yes. But 25% of what? It's going to be 25% of 8 units, or 1/4 of 8 units, and that will be 2. So we can say that 2 units over here will be shaded, correct? And then the next thing we can see is that 3/5 of the medium square is shaded. So over here we don't really have to crack our brain. If it's 3/5 of 5 units, this is very convenient because this means to say that you have got 3 units of B, square B, being shaded. Now what about square C? What is square C's shaded portion? B is equal to 33%. No, 3/5 is not. What about C? Do you all know? Can you infer what C has to be? What C's shaded portion has to be over here? Okay, Lina Liao, you got it? Okay, you got it? Alright. Yeah, it has to be 1 unit because if the total here adds up to 3 units, then the last remaining portion will be 1 unit over here. And once you got this already, we can fill up the unshaded portions conveniently. 6, 2, and 2. So what does this mean? This unshaded portion of A will have an area of 6 units. The unshaded portion of B will have an area of 2 units. And the last part here, unshaded area of 2 units for C. So now that we've got that, now that we've defined out everything, we want to find out what percentage of the whole figure is not shaded. So this part is rather convenient. You want to find out the unshaded portion first. And that will just be 6 plus 6, 6 plus 2 plus 2. That will give you 10 units worth of unshaded portion. Correct? But this part is where a lot of you will have very different answers. How many units make up the total area? US is unshaded. Okay, so who thinks that the total area is 16? Is 16 units worth? Who thinks that is 16? If I see that your answer is 62.5%, you're probably thinking of this. Alright? What is the total area of the figure? So this is where you all need to be careful. Okay, so I'll give you all some time to reply. Give you all some time to think, give you all some time to reply. So instead of giving you the poll, this is what I want you all to think about. You all want some music to go along with it? Okay, so what is the area of the figure? The area of the figure is this. Okay, where is this figure actually? So the whole figure's outline is this entire square 3 of the outlines. Okay, if you take 8 plus 5 plus 3, this is a one big confusion alert. Okay. Total area is not. Eight plus 5 plus 3, yeah? Because if you do this, you are assuming that all three squares are not connected to each other. You're saying that all three squares are disjoint in this case. So this is not the case. There is some overlap, and because of this overlap, it eats into the area of the squares. So to deal with this, I have already conveniently listed this out for you. You can break them down into the unshaded portion of A, unshaded A, plus the total area of B, plus the unshaded portion of C. Okay, or if you want to go by a safer route, you can also say that you want to take the unshaded portion of A plus the shaded portion of A plus the unshaded portion of B plus the shaded portion of C and plus the unshaded portion of C. So that there are other ways you can calculate the total area, but I want to go for safety here. So this would be 6 plus 5 plus 2. This would give you 13. And once you got this already, the percentage of the whole figure that is not shaded will be 10 out of 13 times 100%. Okay, careful here. Ten out of 13 times 100. Jaden, did you just join? So 12 out of 13%. Yeah, Lena, the total area is 13 units because of the overlap. The area of the whole figure is how large is this entire surface? You know what I'm saying? Okay, it's not that you take 8 plus 5 plus 3. If you do this right, you are saying that the three squares area are all disjoint. You're taking square A's area plus square B's area plus square C's area, all separately added up together. Okay, no, I'm not going to give you the poll. Right? But in the exam hall, do we have to change it to 1 or 2 decimal place? If they specify 2 decimal place, then you do it. If not, just leave it as this in the exact form. Okay? Okay, if you got it, please spam the like button. I honestly don't know what's wrong with my phone today. So I can see I can see all the floating faces, but I cannot see the video playing. You literally paused? No lah, I'm still in real time, but video itself got something wrong. What is the answer? This will be the answer. Alright? What phone you use? Note 9. Reset my phone. Is this possible to be tested in PSLE? I would say yes. Okay, because this is one of those questions where it's not too technically difficult, but it's tricky because of the way people would define the total area. You understand what I'm saying? It's one of those not so technically difficult questions, but tricky. Okay, Jaden, later you just watch the replay. I think you came in late or something. You just watch the replay. Okay, so you got it ready? I still got 2 more questions to go. I need to wrap this up by 9. So let's go on to example 4. So before you move on, this idea here is on repeated identity. Okay. No, that is not 15. That is 13. This is not 15. This is 13. Okay, let's move on to number 4. Okay, 4 out of 7. 3 out of 5. Your webcam is blur. No, I don't think it is. Yeah. Okay, so over here you see that Madam Ong had a total of 754 red and blue buttons. She used 4/7 of her red buttons and 3/5 of her blue buttons to sew a quilt. At the end, she had an equal number of red and blue buttons remaining. How many buttons did Madam Ong use altogether? Now to deal with this, you can see that this is your before. Within this little statement over here contains information about your before, your change, and your after. She had an equal number of red and blue buttons remaining. So how many buttons did Madam Ong use altogether? Hey Jaden, Dallas, you're correct. Can you play music? No. You get to enjoy my monotonous voice in all its glory. So over here you got red and blue. Total, used, remain. Okay. So for the red buttons, let me use red color for this. Now, for the red buttons. Yep, Dallas, you're correct. Music. So the total here is 7. You had 7 blocks of red buttons, right? You used 4 of them, and now you're left with 3. For the blue buttons, you had 5 blue blocks. You used 3 blue blocks, and now you have 2 blue blocks remaining. Okay, I think not too sure whether is it my issue or yours. Okay, so once you got this ready, you can see that you had an equal number of red and blue buttons remaining. Okay, so anyway, 3 red blocks represents the same amount as 2 blue blocks. We say that these two are equal, we make them the same. Okay? That is the informal way of putting it. So anyway, this becomes 6 and 6. We multiply the whole row by 2 to maintain equivalence, and then we would have this. Straightforward, yeah, I know. But you still see people having issues with these types of problems. So this is how to break it down. So once you got that ready, the next thing you want to do is look back at the question for further info. They had a total of 754 red and blue first. So you want to take 14 units plus 15 units to give you 29 units here. That will represent 754. So once you're done with that, you can find out 1 unit first. That will be 26. And the number of buttons that she used altogether. So that will be 8 plus 9 units. 17 units will be 442. So most of you got this correct. Okay, Jamie, Melvin, Maggie, Corley Ling, Jennifer, Jen. Yeah, okay, hang on. You let me try to fix something first. Let me test out something. Maybe the Wi-Fi isn't coming into my room that well. So let me open up the door. Hopefully this will allow the Wi-Fi to come in better. Okay, Victor, Wayne, Ian, you got it. Okay? You try to rotate this. Try to rotate this sideways first. Like, wait. Why is this so bad? What is the issue that you are facing right now? But there are a bunch of people who are okay with it. I do not think Wi-Fi works this way. Yeah, Janelle, you're correct. Okay, if you got it, please spam the like button. And then you see Kayla say it's okay already because after I open the door, the Wi-Fi come in. No, but that's pseudoscience. For science, all science matters. Please consult Mrs. Linda Cole for it. Alright? I can see everything. Okay, so now ready for the last one? This, as you can see, for example 4, is also on equal concept. Main idea here is on equal concept. Okay, Right, then next one, the last one, which is the final boss for today. So 3/7 of Jack's money is equal to 2.5 times of Gil's money. When Jack spent $155 and Gil saved $22 more, Jack's money became thrice of Gil's money. How much money did Gil have at first? So over here you can see that this is your before, there is a change over here, and there is an after. So it looks very simple, right? Because right now you have fewer words than the previous questions. It looks simple, right? Usually when the question is shorter, right, that's where it gets more scary for me, at least in university, because I remember they had one 25 mark question for me for economics. Okay, they gave this question: inflation is always and everywhere a monetary phenomenon. Then full stop, discuss. Then after that, the marks allocation for this was 25 marks. So sometimes when it's shorter, it's not necessarily going to be easier. So anyway, once we got this ready, first things first, change this to a fraction first. An improper fraction. This will be 2 whole and a half. Simplifies now to 5 out of 2. Now let's simplify the problem first. Yeah, my Jade or Faith told, yeah, that's kind of true also. Okay, so let's look at what's happening before first. Here we have Jack and Gil. There is a compared portion. You have to use a combination of techniques over here already and total. So let's break this down one by one first. If you try to do everything at once, you will be overwhelmed. So this is 3 out of a total of 7. And for Gil, you are comparing 5 out of a total of 2. Okay, so once you have this already, we say that the compared portion is equal. So we want to make them the same. Okay, so make them the same first. Between 3 and 5, lowest common multiple is going to be 15. Okay? Yeah, Maggie, you're correct. So the whole moral of the story for the before statement is that Jack had 35 units while Gil had 6 units at first. Okay? So with this in mind, we can proceed to analyze it using the before and after table. Okay, so now that we got that ready, we can just plug those in. Okay, 35 and 6 first. Then now we list out the change. Jack spent $155 and Gil saved another $22. Jack's money became 3 times that of Gil's money. Okay, so far? Yeah, let me take a look at this. Eh? Why like that? Jialat. What is BCA? Before change and after. Okay, so now my next question is for those of you who have been following us since the beginning of the year. When you look at the change row, what kind of change condition is this? Back to blurriness. Okay. Okay, are you all still there? Wait, let me reply to Li Ling first. Okay, got it. All change. Yes, Dina, you're correct already. Everything changes. So over here, in order to deal with an all changing quantity problem, you will need to say that this is 35 units, 6 units, 3 parts, 1 part. And once we got that, we will have 35 units minus 155 giving you 3 parts, then 6 units plus 22 to give you 1 part. Okay, so in order for you to find out how much money Gil have at first. Which is 6 units in this case. Remember the shortcut. To find U, you need to make P the same. Okay, this is where it starts glitching out. Okay, the main idea here is that when you want to find units, you need to make parts the same because you want to get rid of the parts. So in maths, like what I always say, this is a rather lame joke. Okay, but if it helps you to remember it better, I'm glad it will help you remember. Okay, the idea here is that whatever you don't need, you want to get rid of them. In maths, it's a very cruel world. Okay, whatever you don't need, you get rid of them. So in this case, you don't need the parts. You want to get rid of the parts, so you make parts the same. Right? When you do it like this, you end up with 18 units plus 66 equals to 3 parts. And once we got this, we can now focus on drawing out these two models to represent that. We would have 35 units minus 155 giving us 3 parts. So remember how this happens, how to draw out the model. You draw out 35 units first, you take away 155, and now you're left with 3 parts. Okay, then for the next one, we have 18 units and 66 adding up to the same 3 parts over here. So once you got that already, remember the mantra. Okay, hopefully you all dream of it at night, and hopefully the mantra goes with you into the exam hall. Here, in order to find out the value of 1 unit, because your parts has been made redundant, okay, we want to say that you need to compare units with units, numbers with numbers. So this will give you 17 units here. And 66 plus 155 will give you 221. So 70 units represents 221, then 1 unit will represent 221 divided by 17 to give you 13. And if 1 unit is 13, then 6 units would simply have a value of 78. So the answer here then will be $78. Okay, there you have it. Okay, Kayla, that will work as well. Sorry, I really don't know what's going on for some of you. I can't pinpoint the issue from here. Okay, Janelle, you got it too. You can spam the like number if you want. Yeah, $78. But make sure in the exam when you do it, you write down the units as well. Okay? Okay, so anyway, coming back to this, this requires a combination of heuristics. This one is on equal concept. With all changing. And certain other questions will also require you to probably use something like repeated identity to simplify the problem first, and then followed by single unchanged quantity or something along those lines. So for more of these questions, you can refer to the Mastering Heuristics Series, which I've pinned in the comment section down below. And okay, if you need to replay this, you can always go to mathsheuristics.com/blog. Okay, it will be there at least until the end of this year. At least until the end of this year. So don't worry about it. If you have prelim, it is more important, definitely take care of that first. Okay, you can watch the replay later on, I'm okay with it. Because our purpose here is to educate. Alright, if you found this useful, please like and share. Okay, you're welcome, Jermaine. Are we supposed to have 2 calculators? Janelle, just go to the blog post. Just go to the blog itself. It's all available there. Okay, I'll tell you a story. Okay, story time with Kevin. Okay, Kayla. What happened was, I think back in 2017, 2016 or 2017, I can't remember the exact year. But the thing is, there was one question in paper 1, right, where you had to measure the angle. I think it's question 23. So I'm not sure whether this is 2016 or 2017. So the student forgot to bring his protractor in there. And he had to forgo that 1 mark. Because he couldn't measure it. But the thing is, he still got his A star. Okay? So for whether or not you want to get 2 calculators will be extremely safe, but whether or not it's worth the additional money, if money is not the issue for you, just get it. You know what I'm saying? If spending that $25 plus or what can buy you a peace of mind, just do it. But yeah, I think if I'm not wrong, you have to go and get your calculator certified that it is one of those compatible models that you can bring into the exam hall. No lah, 2 is 2 is safe enough already. It's like the probability of the calculator breaking down in the exam hall itself is actually pretty low. So if you have 2, it makes it very low already. I think in fact, if you want to buy Toto and Strike, I think it's easier. Okay, see you, Ki Liang. You're welcome, Ian. Have fun with those books that you purchase. Anything don't know, you can ask me, right? Okay, so who else needs anything? Anyway, we've ended already. 1 hour, clear 5 questions. If you're in my real class itself, it's probably 1 hour, clear 9. So here is more relaxed. You're welcome, Wei Ching. So am I done? Yes, I'm done already. Can I buy the books here? Yes, you can use the link to purchase the books. Have no fear, Kevin is here. So I'm gonna remember. No, I'd rather you remember all the mantra that I've been reciting. Compare units with units, numbers with numbers. Yeah, I'd rather you all remember all those mantra. These 2 are equal, make them the same. Look for the repeated identity first whenever it's possible. Blah 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 blah. Okay? Yeah, you're welcome, Janelle. Okay, bye, Delvin. Kira, you and you all know how to do all those funny emojis. Till next time. Alright, man. Okay, any questions? Yeah, of course, Delvin, dude, you see the fun we're having? Okay, any other questions? If not, I'll take my leave already. Need to start looking at all my other students' papers already. Need to see what they're doing correctly, what they're doing wrongly and all that. Okay, see you, Lina. See you, Kayla, in class tomorrow. It's lots of fun. No, I honestly mean it. Do you know that for me, you know what is my main application of mathematics when I was younger? Y'all will be surprised. my main application of maths is on high scoring for games when I was younger. And I have 4 world records currently still standing. I had more than that, but some of them got taken over already. And especially for TC4, you need to justify every single action. Every single action will either give you score or will make you lose score. That was when it was very, very crucial. But anyway, that's enough of me. Talk to you all again soon. Okay, good night. Stay safe. Thank you for having me. My name is Kevin. See you all next week. Bye bye.